Hello, my dear students. Today we are going to continue chapter 3. We are going to discuss the last part of chapter 3. We are going to discuss the concentration of hydroxyl ions, and we are going to discuss the ionic product of water, and we are going to discuss the hydrolysis of salts, and we are going to discuss the solubility product. So let us start. Calculation of concentration of hydroxyl ion for weak bases. Ammonia gas is a weak base and it dissolves in water, as ammonia that dissolves in water gives ammonium ion and hydroxyl ion. So at equilibrium, Kb equals concentration of ammonium ion times the concentration of hydroxyl ion over the ammonia gas. So my dear student, each mole of ammonia gas ionizes into 1 mole of cation ammonium ion and 1 mole of anion hydroxide ion. So the concentration of ammonium ion equals the concentration of hydroxyl ion. So ammonium ion concentration equals concentration of hydroxide ion as shown on the screen. So Kb for the reaction equal the concentration of hydroxide ion power 2 over the concentration of ammonia gas. So Kb equal concentration of hydroxide ion power 2 over the concentration of ammonia gas. As the ammonia gas is weak base, so the number of moles of ionized ammonia are very small, so they can be neglected. So we can say the concentration of unionized moles of ammonia equal original concentration of ammonia equal C. So we can substitute it in the Kb equation. So Kb equal concentration of hydroxide ion power 2 over concentration of ammonia C. So hydroxide ion equals the square root of Kb times C, and this in molar solution. We are going to discuss example on Kb for base. Here, calculate the concentration of hydroxyl ion in 0.1 molar of ammonium hydroxide solution at 25 degrees Celsius, given that the equilibrium constant Kb equal 1.7 times 10 to the power negative 5. Solution: the concentration of hydroxide ion equals square root Kb times C. So equal 1.7 times 10 to the power negative 5 times 0.1. So 1.33 times 10 to the power negative 3 molar. Now we are going to discuss the ionization of water. The pure water is a weak electrolyte which ionizes very slightly as following. As shown on the screen, water plus water molecules as the molecules present gives hydronium ion and hydroxide ion. So as simplified dissociation, it can be written as water gives hydrogen ion and hydroxide ion. So my dear student, here Kc equal hydrogen ion concentration times the concentration of hydroxide ion over the concentration of water. Since the degree of ionization of water is low, so it is almost found as unionized molecules. So the number of unionized water molecules is constant. So Kc times the concentration of water equal constant value equal Kw, so equal 10 to the power negative 14. Therefore Kw equal concentration of hydrogen ion times concentration of hydroxide ion, so equal 10 to the power negative 14. So we can define the ionic product of water Kw. It is the resulting of multiplying the concentration of hydrogen ion times the concentration of hydroxyl ion, which equals 10 to the power negative 14. So concentration of hydrogen ion times concentration of hydroxide ion equal 10 to power negative 14, which is Kw. So, my dear student, the concentration of hydrogen ion and hydroxide ions are inversely proportional to each other. So, if the concentration of hydrogen ion increases, the concentration of hydroxide ion decreases with the same value. So, we have good reason in this point. Water has neutral effect on litmus because the concentration of hydrogen ion equals the concentration of hydroxide ion, which equals 10 to power negative 7. As the concentration of hydrogen ion times the concentration of hydroxide ion equal 10 to power negative 14, and since hydrogen ion concentration equal concentration of hydroxide ion, so the concentration of hydrogen ion equal concentration of hydroxide ion equal 10 to power negative 7. My dear student, it is difficult to use these small values with negative power of 10 in scientific and applied terminology. So, we use the expression of hydrogen exponent. Here we call it pH value. It is the negative logarithm of hydrogen ion concentration. We can say it is a way for expressing the degree of acidity or alkalinity for aqueous solution. My dear student, notice that the letter B indicates the negative logarithm or negative log. So, my dear student, pH equal negative log of hydrogen ion concentration. So, equal negative log also of hydronium ion concentration. And it gives positive values from 0 to 14 as shown on the screen. So, in acidic solution pH less than 7, and in basic solution pH is greater than 7, and in neutral solution pH equals 7. Here some common values for pH: lemon 2.3, seawater 8.5, blood 7.4, urine 5.5 till 7, saliva 6.5 till 7.5, gastric juice from 1 to 3. Here, my dear student, as we know as Kw equal the concentration of hydrogen ion times concentration of hydroxide ion equal 10 to power negative 14. So, negative log Kw equal negative log H positive plus log OH negative. So, equal negative log 10 to power negative 14. My dear students, substitute the value of negative log by letter B. So, BKW equal BH plus BOH, so equal 14. Therefore, BH plus BOH equal 14. In case of neutral solution, my dear student, as pure water, the concentration of hydrogen ion equal concentration of hydroxide ion equal to 10 power negative 7. So, BH equals 7 and BOH equals 7. In case of acidic solution, the concentration of positive hydrogen ion is greater than concentration of negative hydroxide ion. So, BH is less than 7 and BOH is more than 7. In case of basic solution, concentration of hydrogen ion is less than concentration of negative hydroxide ion. So, BH is greater than 7 and BOH is less than 7. We are going to discuss some problem on these values. Complete the following table. Here, the concentration of hydrogen ion, hydroxide ion, BH, BOH, and solution. These values are written in the table. We are going to complete the missing blanks. So, concentration of hydroxide ion equal 10 to power negative 12, and BH here negative log H positive equal 2, and BOH negative log OH negative equal 12, and solution is acidic as BH is less than 7, which equals 2. For the second row, the concentration of hydrogen ion equal 10 to power negative 9, as, my dear student, the concentration of hydrogen ion times concentration of hydroxide ion equal 10 to power negative 14. So if we divide 10 power negative 14 over 10 to power negative 5 equal 10 to power negative 9. And here pH equal negative log Z B, the concentration of H positive, so pH equal 9. And here BOH, here negative log the concentration of hydroxide ion equal negative log 10 to power negative 5 equal 5. And solution is basic as pH is greater than 7. Here the concentration of hydrogen ion 10 to power negative 3 as the pH equal 3, and the concentration of hydrogen ion equal 10 to power negative the value of pH. And here the hydroxide ion concentration 10 to power negative 14 over 10 to power negative 3 equal 10 to power negative 11. And here BOH equal for 11 as 14 minus BH gives the values of BH. Here the BOH equal 11 as 14 minus 3. And solution here is acidic as BH equal 3, which is less than 7. Here, my dear student, as the BOH equal 7, so concentration of hydrogen ion equal 10 to power negative 7, and the concentration of hydroxide ion equal 10 to power negative 7, and pH equal 7, and solution is neutral. Next example, calculate the concentration of hydrogen ion and the concentration of hydroxide ion and pH and BOH in 0.1 molar of acetic acid, where the equilibrium constant of the acid Ka equal 10 to power negative 5. Here solution, the acetic acid plus water in equilibrium gives acetate ion and hydronium ion. Here the hydrogen ion equal the square root of Ka times C, so equal square root 10 to power negative 5 times 0.1, so equal 10 to power negative 3 molar. Here, my dear student, the pH equal negative log the concentration of H positive, so equal negative log 10 to power negative 3 equal 3, and the BOH equal 14 minus BH, so BOH equal 14 minus 3, so BOH equal 11. Here the concentration of hydroxide ion equal 10 to power negative 14 over concentration of H positive, so 10 to power negative 14 over 10 to power negative 3, so equal 10 to power negative 11. The next example, calculate the pH and the BOH for hydrochloric acid where its concentration is 0.03 molar. My dear student, remember that the acid here is strong and completely ionized, so the concentration of the hydrogen ion equal its concentration. So by solving this problem, pH equal negative log the concentration of hydrogen ion, which is negative log its concentration, so negative log 0.003 equals here 3.52. So BOH equal 14 minus LBH, so BOH here equal 14 minus 3.5, so BOH here equal 10.48. Another example, find the following for acetic acid, where its concentration is 0.5 molar and its ionization constant Ka equal 1.8 times 10 to power negative 5. Calculate the degree of ionization of the acid and the concentration of hydronium ion in the solution of the acid and the pH of the acid and the BOH of the acid. Solution, here alpha equals the square root of Ka over C, so square root 1.8 times 10 power negative 5 over 0.5 equal now 0.5 times 10 to power negative 4. And here hydronium ion equals square root Ka times C, Since Ka equal alpha square times C, so hydronium ion equal alpha square times C. So here hydronium ion equals alpha times C, so 9.5 times 10 to power negative 4 times 0.5, so equal 4.8 times 10 to power negative 5. Here pH equal negative log the concentration of hydrogen ion, so negative log 4.8 times 10 power negative 5 equal 4.32, and the BOH equal 14 minus the pH, so BOH equal 14 minus 4.32, so equal 9.68. Another example, find the following for ammonium hydroxide solution or ammonia solution, where its concentration 0.1 molar and its ionization constant Kb equal 1.6 times 10 to power negative 5. The degree of ionization, then find the degree of ionization of the base, and then concentration of hydroxide ion solution, and the BOH of the solution, and pH for the solution. Solution of the problem equals the square root of Kb over C, so equals square root 1.6 times 10 to power negative 5 over the 0.1, so equal 1.27 times 10 to power negative 2. So OH negative equal Kb times C square root. Since Kb equal alpha square times C, so OH negative equal alpha square times C. So here the OH negative equal alpha times C equal 1.27 times 10 power negative 2 times 0.1 equal 1.27 times 10 to power negative 3. And here BOH equal negative log of OH negative, so negative log 1.27 times 10 to power negative 3 equal 2.9, so BH equal 14 minus el BOH, so BH equal 14 minus 2.9, so equals 11.1. Now we are going to discuss the hydrolysis of salts. The hydrolysis means it is a dissolve of solid salt in water to form acid and alkali, which is acid which the salt is derived from them. The hydrolysis is opposite to neutralization. So salt plus water here by hydrolysis gives acid and alkali, and the reverse is neutralization process. Here, my dear student, remember the strong acids, for example, as halogen acids, HCl, HBr, HI, hydrochloric acid, hydrobromic acid, hydroiodic acid, and oxygenated acids as perchloric acid, sulfuric acid, and nitric acid, and weak acids as carbonic, hydrocyanic, nitrous acid, organic acids also weak acids as acetic acid, CH3COOH. Strong bases here has hydroxides of group 1A and 2A, sodium hydroxide, potassium hydroxide, cesium hydroxide, magnesium hydroxide, barium hydroxide, and weak bases ammonium hydroxide, iron 2 hydroxide, iron 3 hydroxide, and aluminum hydroxide. So we are going to discuss the hydrolysis of some salts. Hydrolysis of sodium carbonate, Na2CO3, and we have give reason for this point. The sodium carbonate solution is alkaline because sodium carbonate is ionized in water, giving weak acid and strong alkali, and so water is ionized as weak electrolyte. As the equation proceeds on the screen, it giving hydrogen ion and hydroxide ion, and sodium carbonate is ionized in water into sodium ion and the carbonate ion. And here, as sodium carbonate gives with water, carbonic acid as it is formed as it is weak acid, and the sodium ion and the hydroxide are present as its strong electrolyte, strong base. So we can say sodium hydroxide is not formed because it's a strong electrolyte and completely ionized, and the carbonic acid is formed because it is weak acid and weak electrolyte and incompletely ionized, so the concentration of H positive decreases and ionization of water shifts forward. Thus, concentration of OH negative increases according to Le Chatelier principle. Therefore, sodium carbonate solution is alkaline, turns the red litmus into blue, and pH is more than 7. Hydrolysis of ammonium chloride, and we have give reason for this point. Here, ammonium chloride solution is acidic because ammonium chloride is ionized in water, giving strong acid hydrochloric acid and weak alkali ammonium hydroxide. As water is ionized as weak electrolyte into hydrogen ion and hydroxide ion, and the ammonium chloride ionized into ammonium ion and chloride ion, so ammonium chloride plus water gives ammonium hydroxide and hydrogen ion and chloride ion. As the ammonium chloride is ionized in water into ammonium ion and chloride ion, we find that hydrochloric acid is not formed, as it is a strong electrolyte and completely ionized. Ammonium hydroxide is formed, as it is weak electrolyte and incompletely ionized. So the concentration of hydroxide ion decreases and the ionization of water shifts forward. Thus, the concentration of hydrogen ion increases according to Le Chatelier principle. Therefore, my dear student, ammonium chloride is acidic and turns blue litmus into red as pH is less than 7. Next example, hydrolysis of sodium chloride solution. And we have good reason for this point. Sodium chloride solution is neutral because sodium chloride is ionized in water, giving strong acid hydrochloric acid and strong alkali sodium hydroxide. So, my dear student, water is ionized as weak electrolyte into hydrogen ion and hydroxide ion, and here sodium chloride is ionized as sodium ion and chloride ion. So, sodium chloride that dissolves in water gives all the ions, sodium ions and hydroxide ions and hydrogen ion and chloride ion. So, both of sodium hydroxide and hydrochloric acid are not formed, and that's why they are strong electrolyte and completely ionized. So, the concentration of hydroxide ion equal concentration of hydrogen ion. Therefore, solution is neutral and has neutral effect on litmus paper, and pH equals 7. Next example, hydrolysis of ammonium acetate. And we have good reason for this point. Ammonium acetate solution is neutral. The reason for that because ammonium acetate is ionized in water, giving weak acid, acetic acid and ammonium hydroxide. And water is ionized as weak electrolyte into hydrogen ion and hydroxide ion. So, my dear student, ammonium acetate is ionized as ammonium acetate into acetate ion and ammonium ion. So, the ammonium acetate that dissolves in water gives acetic acid and ammonium hydroxide, as both of them are formed, which are weak electrolyte and incompletely ionized. So, the concentration of hydroxide ion equals the concentration of hydrogen ion. Therefore, the solution is neutral and has neutral effect on litmus paper, so pH equals 7. Now, my dear student, we are going to discuss the solubility product. On adding a solute to a solvent at certain temperature, we find that the salt and solvent that form the solution, the solvent dissolves the solute till reach saturated solution and become unable to dissolve more solute. And adding excess solute precipitate in the solution, and an equilibrium arises between the solute and the solution. And here the rate of solubility equals the rate of precipitation. So, the concentration of the solution remains constant. My dear students, we have reached to the end of our program today. I hope you understood all the points and problems that we discussed today. So till we meet again, my best wishes for you.